Hi everyone, I am Dr. Ravichandra Janapati, Professor of EC Department, SR University, Warangal. In today's lecture, we will discuss topologies in a computer network, and transmission medium. These are the two topics we are discussing in today's topic in this video. Now, first of all, we will discuss types of topologies. There are different types of topologies. In that, first one, mesh topology, star topology, tree topology, bus topology, ring topology, and hybrid topology. So these are the different topologies in a computer networks. So what is mean by topology? Topology means it is a physical lay or texture. For example, if we want to construct one building, first we have some physical structure, physical drawing. Like that, we have how we are connecting the network, how the physically that networks will be connected. That is known as topology. In that, there are different types of topologies are there. Just now we have mentioned that are mesh topology, star topology, tree topology, bus topology, ring topology, hybrid topology. Now, first topology here, mesh topology. In mesh topology, here, every device that has a direct point-to-point link between every other device. In mesh topology, there is a direct link from one device to other device. That is called as mesh topology. It is a fully connected mesh can have n into n minus 1 physical channel to link n device. For example, n devices are there, then n number of nodes are there, then how many we need n into n minus 1 by 2. Why divided by 2 here? For transmission receiving. So we are using only one channel or one link. So here we need n into n minus 1 by 2 links are required. So for example, if n is equals to 5, the number of nodes are 5, then what we have to write? 5 into 5 minus 1 by 2, which is equals to 10. Then 5 nodes are connected by using 10 communication links. Now we need 5 into 4 by 2, which is equals to 10. So then how many links are required? 10 links are required. So this is a mesh topology. So this is the diagram for mesh topology. For example, there are 5 devices are there, like A, B, C, D, E. There are 5 devices are there. Now, according to the definition, this mesh topology means every node is a direct connection from two other nodes. Every node is having direct connection to other nodes. For example, you take A directly connected with B. Now A is connected with C. A is connected with D. A is connected with E. Similar way B also. B is A, C, D, E. Next C also. C with A, B, D, E. D also. So every node is directly connected with the other node. So here there are 5 nodes. Just now we have discussed 5 nodes means number of links L is equals to 5 into 4 by 2, which is equals to 10 links are required. Just now we have discussed. So how many links are required? 10 links. Just as here, one link, 2, 3, 4, 5, 6, 7, this eighth link, ninth, 10th. So these are the links are required. Now, what are the advantages of mesh topology? What are the advantages of mesh topology? So here we have advantages. It eliminates the traffic problem. It is robustness. It has privacy and security. Fault can be easily found. So it eliminates the traffic problem. First one, it is robustness. Another advantage, it has privacy and security. Fault can be easily found. So these are the advantages of mesh topology. Now, what are the disadvantages? Disadvantage of mesh topology. Here, more number of cables to be used. That is a disadvantage. Now, every devices must be connected to some other device. So installation process is very difficult. It is complex also. One is cost. Cost is high. Cost is high, as well as complexity also, and installation process also very difficult. So these are the disadvantages of mesh topology. Now next one, star topology. Star topology. Every device has a dedicated point-to-point link between only a centralized controller or hub. So there is no link here, but there is no direct link connection from one device to another device. We have one hub. That hub connected to other devices. That hub connected to other devices. Now, the devices are not directly linked to some other devices. There is no direct connection from one device to another devices. If one device wants to send data to another device, it sends to the central controller. First, if one device wants to send data to another device, it sends to central controller first, and the central controller send to the device. So first, if any device want to here, first it will send to the central controller, then the central controller send the device to another device. Now this is the diagram for star topology. So in this topology, we have 4 devices are there: A, B, C, D, and we have one central controller or hub. So this hub, it acts like a server. Now, any device want to communicate with other devices, first it will send the information to this particular hub, all the devices. Then from this hub, forward the data to other devices like this. And this hub forward the data to other devices. And the star topology is also having its own advantages as well as disadvantages. First, advantages. It is less expensive than mesh topology. First advantage, it is less expensive than mesh topology. Then it is less number of cables to be used. Here we have to use less number of cables need to use. That is another advantage. Here there is no need of if 100 devices are there, there is no need of 100 into 50, 100 into 99 by 2. That is not required here. Next, it is robustness. It is a robust. That is the advantage. Now, disadvantages. We have some disadvantages of this method also. One, each device must connect it to the central controller. Each device must connect to the central controller. It requires more installation process. For example, 100 devices are there. That 100 devices need to connect to the central controller. So, okay, if that central controller is fine, no problem. But if central controller failure means all the devices should be failed. Central controller fails means central controller failure means all the devices should be failed. Now, next another topology is tree topology. Tree topology. Here, tree topology has some variation from star topology. Now, the nodes in the tree are linked to the central controller. The primary hub in the tree is represented by active hub. The secondary hub in the tree is represented by passive hub. The primary hub in the tree is represented by active hub. The secondary hub in the tree is represented by passive hub. Now, this is the diagram for tree topology. This is the tree topology diagram. We have A, B. We have central controller or hub. This will give the information to this central controller hub. Now this is an active hub, and this hub is connected to another sub hubs. There is no, in previous case we have only one hub, but we this connected to another sub hubs. Now, because of this, the load on one particular hub that can be reduced, and we can process the information independently, and the speed of the network also increased. So if one hub fails means, okay, we can reconfigure the network. So that is the advantage. Now, advantage. It allows more devices to be attached in a single central controller. It allows more devices to be connected, attached in a single central controller. And also, it allows the network to prioritize the communication. It allows the network to prioritize the communication. So these are the advantages of topologies. Disadvantages. Each device must be linked to a central controller. Each device must be connected, linked to a central controller. It requires more installation process. It requires more installation process. Central controller failure means the entire system should fail down. This is also one disadvantage. It requires more integration process. Each device must be linked to the central control. Now, next, another topology is bus topology. A bus topology describes the multi-point configuration. That means one long cable acts as a backbone to link all the devices in a network. A bus topology describes the multi-point configuration. One long cable acts as a backbone to link all the devices in a network. Devices are connected in a bus topology with the help of drop line and tapes. Devices are connected topology with the help of drop lines and tapes. Now, this is bus topology. We have end-to-end device. Next, this is backbone. Now we have A, B, C, D devices. This is the drop line. Now we want to connect these devices through a drop line. So in this bus topology, we use one cable to connect all the devices. So we have drop lines as well as tapes and backbones in this bus topology. Next, advantages. Advantages of bus topology. Installation process is very easy. In bus topology installation, just one cable that will be laid down. Hence, installation is easy. Redundancy can be eliminated, so we can reduce the redundancy, and less number of cables to be used. Can use less number of cables. Now, disadvantages. What are the disadvantages of this particular bus topology? So reconfiguration is very difficult. In bus topology, reconfiguration is very difficult. It is very difficult to adding or deleting of a devices. It is very difficult to adding or deleting of a devices. So that is also bus topology. Disadvantage of bus topology. One is reconfiguration is very difficult to adding or deleting of a devices. Next, another important topology is ring topology. Ring, that means all the devices that are connected in the shape of ring. All the devices that are connected in the shape of ring. In ring topology, each device has dedicated point-to-point link between other devices. In ring topology, each device has a dedicated point-to-point link between other devices. The signals are passed along the ring in only one direction from device to device. The signals are passed along the ring in only one direction from device to device. Now, each devices in a ring should have a repeater. Each devices in a ring should have a repeater. Now, this is the ring topology. The devices are connected in a ring. A, B, C, D. Now, in this ring topology, the node which want to transmit the information, it should have token. Then once that once it sends the information, it releases the token. In a similar way, the station B, if it wants to send the information, first it captures the token, then it sends the information. Once it sends the information, it releases the token. So that is the process in ring topology. Advantages: easy to install and reconfigure. It is very easy to install and reconfigure. And also, fault can be easily identified. Fault can be easily identified. So that is also another advantage. Disadvantage. Coming to the disadvantages, it is unidirectional traffic. In Ring, if one device gets failure, then the entire system should be failed. It is a unidirectional traffic. In Ring, if one device failure, then the entire system should be failed. Next, another topology is hybrid topology. Hybrid means the combination of all topology called hybrid topology. The combination of star and mesh, the combination of mesh and ring, the combination of star and mesh and ring. These more than one topologies are combined. That is called as a hybrid topology. Now this is the example for hybrid topology. So here we have star topology. Next, another one is ring topology. This is bus topology. This is star topology. So there are different topologies: star, ring, bus. So it is all the different topologies are connected. Why we have done so? Because each and every method topology is having its own advantages. We have done this. Okay, thank you. Next, we will discuss next topic, that is transmission media. Transmission media. What do you mean by transmission media? Transmission media means the physical path between transmitter and receiver. That is called as a transmission media. Physical path between the transmitter and receiver. Repeaters or amplifiers may be used to extend the length of the medium. Repeaters or amplifiers may be used to extend the length of the medium. So communication of electromagnetic waves is guided or unguided. So it may be transmission media, may be guided or unguided, may be wired or wireless. So this is regarding transmission media. In the transmission media, we use repeaters or amplifiers. They may be used to extend the length of the medium. So here the repeaters which repeats the signal, and amplifiers which increases the length of the signal. can be used to extend the length of the medium. Next, another one is communication of EM waves is guided or unguided. It may be wired or wireless. Now, here, this is a data transmission. So data transmission can be different types. So this data transmission that can be divided into two types. One, guided channels. Another one is unguided channels. In guided channels, we have twisted pair cable, coaxial cable, optical fiber. So these are the guided channels. So in unguided channels, we have radio waves, microwave, infrared wave. So this comes under unguided or wireless. Guided means twisted pair cable, coaxial cable, fiber optic cable. Unguided means radio waves, microwaves, infrared. So, guided media. Guided media provide a physical connection using a wire or cable between two devices. Guided media provide a physical connection using wire or cable between two devices. A signal traveling through guided media is directed and contained within the physical limits of the medium. So guided media means it provides a physical connection using wire or cable between two devices. A signal traveling through guided media is directed and contained within the physical limits of the medium. So this is called a guided medium. Next. In this first one, twisted pair cable. Twisted pair cable. This cable is the most commonly used and is cheaper than others. It is most commonly used and is cheaper than others. It is lightweight, cheap, can be installed easily, and they support many different types of networks. This cable is the most commonly used and is cheaper than others. It is lightweight, cheap, and can be installed easily, and they support many different types of network. A twisted pair cable consists of two conductors which are normally made of copper. Each conductor has its own plastic insulation, typically 1 millimeter thick. These cables are twisted together. So this is twisted pair cable. This is the twisted pair cable. Each cable is twisted. So now this is the twisted pair cable. Now we have insulator and we have conductors inside, insulators at the outer side. So these things can be twisted. And why it should be twisted means, for example, if any noise injected into this particular one direction, then another after some time it will be in this direction. Then at the outer side, finally we have to take the difference. We will take the difference value Hence, if anything that is affected, if any cable is affected with noise, that noise can be easily removed, or unwanted signal that can be removed easily. Why? Because finally we will take the difference between these two things. So this difference means here, for example, we have this extra 5 volts, extra 5 volts, this 5 minus 5, 0. Why? Because sometimes it is in this direction, sometimes it will be affected this, sometimes it will affect this, sometimes it will affect this. So now if it affects this, then here it will affect this. So because of that, both can be cancelled. Now U2P, STP, unshielded twisted pair as well as shielded twisted pair. Another one is unshielded twisted pair, UTP. So this is the UTP. Next another one is shielded twisted pair. So in this UTP, unshielded twisted pair, we have cables. Outside we have insulators. Inner side we have conductors. And in a shielded twisted pair, we have metallic shield. Then outside we have plastic cover. Next, another one, that is unshielded twisted pair cable. Unshielded twisted pair cable, it is the most common type of telecommunication which consists of two conductors, usually copper, each with its own color plastic insulator. So this RJ45 connector, or we can call it as Ethernet. So this is the most common type of telecommunication which consists of two conductors, usually copper each, with its own plastic insulator. Now, identification is the reason behind curved plastic insulation. Then unshielded twisted cables consist of 2 or 4 pairs of twisted cable. One is pair use RJ11. Now advantages. Installation is easy, it is flexible, cheaper, then it has high speed capacity, 100-meter limit, higher grades of UTP used in LAN technology. One is installation is easy, then flexible, then cheap, has speed capacity, high speed capacity, 100-meter limit, higher grades of UTP. These are the advantages of twisted pair. Now disadvantage. Coming to disadvantage. Bandwidth is low when compared with coaxial cable. This is the twisted cable. So bandwidth is low when compared with the coaxial cable. And also it provides less protection from interference. And it provides less protection from interference. Shielded twisted pair cable. This cable has metal foil or braided mesh covering which encases each pair of insulated conductors. Now, electromagnetic. Electromagnetic noise penetration is prevented by metal casing. That shielding also eliminates crosstalk. It is faster than unshielded and coaxial cable. It is more expensive than coaxial and unshielded twisted pair. Then advantages, it is easy to install, performance is adequate, can be used for analog or digital transmission, increase the signaling rate, higher capacity than unshielded twisted pair, it eliminates the crosstalk. So these are the advantages. Now coming to disadvantages. It is difficult to manufacture. This coaxial cable is difficult to manufacture. Copper is used in this as a center conductor, which can be solid wire or standard one. It is surrounded by PVC installation, a sheet which is encased in an so this is the diagram. Now this is inner conductor. This is insulator. This is outer shield. This is plastic cover. Now BNC connectors. Connector coaxial cable to devices. It is necessary to use coaxial connectors. The most common type of connector is the beyond nail console man, that is BNC connectors. There are three types: the BNC connector, BNC T connector, BNC terminator. There are three types of BNC connectors: the BNC T connector, BNC connector, BNC terminator. So this first diagram, it shows BNC connector. So this is the cable. This is BNC connector. So this is in T shape. So that's what it is called as BNC T 50 ohm BNC terminator. Here at the end, we will use this particular connector. So that's what we can call it as a BNC terminator. So applications include cable TV networks and some traditional Ethernet LAN like 10 base 2 or 10 base 5. Now, outer conductor metal foil, braid or both. The outer conductor is also encased in an insulating filth. The outermost part is the plastic cover which protects the whole cable. Advantage: bandwidth is high, used in long distance telephone lines. It transmits digital signals at very high rate of 10 Mbps, much higher noise immunity. Now, another one is optical fiber. Now, Now we will discuss fiber optic cables. So it is a technology that uses glass or plastic threads fiber to transmit data. A fiber optic cable consists of bundles of glass threads. Then fiber optic cable has bandwidth more than 2 Gbps, gigabytes per second. So this is the structure of the fiber optic cable. Inside we have core, outside we have cladding. Inside we have core, outer side we have cladding. So here the sender is sending the signal, that is fiber optic signal. And here, due to the total internal reflection effect, the signal will be transmitted inside the core. This is called as total internal reflection. This is cladding.